Welcome back to Module 4.7. In this lecture video, we're going to take a look at solving application problems involving with percent increase and percent decrease. So these type of problem is one of my favorites in Module 4. Okay, something called a percent increase and the percent of decrease. So in previous lecture video, I mentioned something about percent is a part. Okay, percent is a part. It means the same thing, it's just in different units. Okay, so percent of decrease, this is percentage, is equal to the amount. Oh Lord, I got all this mixed up now. Darn it. So this first one is percent of increase. I am so sorry, got a lot of typo here. All right, percent of increase, okay, percent of increase is equal to the amount of increase. So this part is percent, this is the actual dollar amount of increase. Part over the whole got to be the original. A trick to know what the original is always know the number you are from. All right. So percent is equal to part over the whole times 100. So for the percent of decrease, it will always be the amount of decrease divided by the original where you are from. Alright, so let me explain to you real quick why I keep on saying the percent got to represent the same thing as the part. Let's say the population of nowhere USA was estimated to be $876,000 in 2005 with an expected increase 5.3% per year. At the percent of increase given, what was expected population in 2006? Okay, so this is not a percent of increase problem. Not really, because it already told me the percent of increase. Suppose the increase 5.3%. So, what is the actual amount of increase? Let's take a look at that. Amount of increase. So, that will be 876,000 people times the expected increase is at 5.3%. In decimal, that will be 0.053. So, part amount of increase is a part of what we were, what the population were. So the amount of increase, part equal to percent times the whole. So 876,000 times 0.053. My expected increase 46,428. 46,428 people. So I'm expected to increase this many. So at this percent of increase given, what was expected population in 2006? So in 2006, that will be the population from 2005 plus the increase. Round your answer to the nearest whole number. So my increase plus 876,000. So we're expecting to have 922,428 people. All right, that's not so bad. Let's look at other example. The population of white-tailed deer in a region was counted to be 212. The population in the same region the previous year was 200. Find the percent increase in the white-tailed deer population. So in the same region, previous year was 200. Now this year is 212. So we actually had an increase. So let me write this down. What people normally do, what students normally do, percent of increase, what students normally do is to take the 200 up here divided by 212, then times 100. Okay, why this is wrong? Why is this wrong? Because percent of increase, your percentage represented the increase, so the part got to represent the increase. Well, Mr. Chen, why don't I just put 212 up here, 200 down here? No, that is still wrong. The part got to represent the increase because the percent and the part got to represent the same thing. 212 is not the increase, 212 is the population now. So, what is the increase? Well, it was 200 last year. This year it become 212. So the actual amount of increase got to be 212 minus 200, which is 12 more deers. So we had a 12 deer increase divided by the original, or where we are from. It was from 200 deer last year to 212 this year. So where we were from is what we're dividing, then times 100. So our percent of increase is 6% times 100. So we have a 6% increase. So remember, percent and the part represent the same thing, just in different units. One is in percentage, one is in dollar signs. Okay, in this case, the part representing how many deers or deer. All right, let's take a look at another one. A man weighed 265 pounds. He lost 25 pounds in 2 months. Then he gained another 25 pounds in 4 months later. So step 1 out of 2 ask, what percent of his weight did he lose in the first 2 months? Okay, so percent of loss. So that's percent of decrease. So percent of decrease is equal to the actual decrease divided by where we were from. All right, what was the decrease? Lost 25 pounds. So the decrease or the lost is 25 pounds divided by where he was from. He was from 265, then lost 25 pounds. So we divide by 265 times 100. So that would tell me the percent of weight lost. Long-term years 100, that would be 9.43%. All right. Now the next question asks, after his initial weight loss, what percent of his weight did he gain? All right. Remember now, he gained back 25 more pounds. Okay. So common mistake will be percent of increase, right, or gain. Well, he did gain 25 more pounds divided by. A lot of students made a mistake right here. They put 265 again, which is incorrect. Remember, the person already lost 25 pounds in the first 2 months. So, then he gained another 25 pounds. So that's 25 pounds he gained divided by where he was from, where he gained from. Where he gained from was 265 pounds initially minus 25, which means after he lost the 25 pounds, he was weighing 240 pounds. Then from 240, he gained back to 265 because he gained another 25 pound back. So now when we talk about percent of increase or percent of gain, is the gain divided by where he was from. So this time he was from 240, gained back 25%, 25 pounds. So times 100 to see what was his percent of increase, percent of gain. Divided by 240 times 100. See, the answer is different. So now he actually gained back 10.42%. Okay, the 10.42% is compared off the 240 pounds where he was, where he was from. So basically, this problem is saying 265 pounds, right? It was from 265 to 240 in the first step. Then, second step, when he gained his way back, that means now he is from 240 pounds back to 265. So this is the from. The first step was this is the from. Okay, so be careful what we're dividing here. All right, so that's a quick lesson on percent of increase and percent of decrease. That will conclude this lecture video. Thank you for watching.